right, let's do this thing. If I have this integral, 7x squared minus 13x plus 13 over and x minus 2 times x squared minus 2x plus 3 dx. Now, if this had been a minus sign back here, we wouldn't even be having a conversation. That would be linear, and we would go with it. But it's not, right? It is not. So I now have a simple linear factor and an irreducible quadratic because that does not factor. So let's set it up. So 7x squared minus 13x plus 13 over x minus 2 and x squared minus 2x plus 3. My linear factor is just that a, bx plus c, and you just go up in variables, right? I mean, we've been doing that this whole time. It doesn't matter what those variables are, the a, the b, and the c. We're just going to solve for whatever that is. Okay. Now multiply through by your common denominator. There is no shortcut to this, BT dubs, right? By the way, I'm getting fancy with my terminology. Oh, goodness. So there is no shortcut to this. That's why I'm saying that shortcut method has a very limited scope. So this one, we have to go for it no matter what. Okay, so 7x squared minus 13x plus 13. So this would be a times that x squared minus 2x plus 3. And bx plus c times that x minus 2. So I have to multiply all that out. So 7x squared minus 13x plus 13 will be ax squared minus 2ax plus 3a plus a bx squared minus 2bx plus cx minus 2c. All right, and there's no like terms there, so we're just writing this stuff out. Then 7x squared minus 13x plus 13. I've got my x squared, so I've got a plus b as my coefficient of my x squared. I've got all three of them for my x, don't I? Negative 2a plus minus 2b plus c. Almost forgot that 2b. And then that's the coefficient of my x term. Then for my numbers, I have 3a minus 2c. All right, let's set it up. I'm going to scoot this up a little bit. So I know a plus b is equal to 7. Negative 2a minus 2b plus c is equal to a negative 13. And 3a minus 2c is equal to a positive 13. How are you going to do this? Think about it, right? Here I have this a plus b and I have this a and the c, so those don't directly go together. Here I have all three variables. All right. Okay. You just pick a couple and go for it. The fact that this one is all three and the fact that this one's a 2 and this one's a 2, you're going to have to put two of these together in order to get that. Like if I were to put these two together right here, then I could look at that and then I could end up with, like, eliminate this b and I could get a new AC equation to put with that AC equation. Do you see what's happening there? So you just have to get creative. Right? Just get creative with it. So I'm going to put these two together. And in order to get rid of this b that I have, I'm going to have to multiply that top by a 2. So I've got 2a. So I'm multiplying this one by a 2 is what's happening here. 2a. Oh my, I don't know where that came from. Plus 2b. And then I'm going to put a space in there equals 7. So I can line it up with the negative 2a minus 2b plus c Uh-oh, uh-oh. I hope you were hollering at me. 2 times 7 is 14, folks. Right? Because I have to multiply this whole thing by a 2. That's what I'm saying. On these deals, you just got to be careful with these systems of equations. You can easily make an error. Oh my goodness, look at this. Oh, that was actually fortuitous, right? Because c is now equal to 1. We get right to the variable. That doesn't always happen, but we take advantage of it when it does. Nice. So now I can plug it in here to come up with a. So we've got 3a minus 2, because it's 2 times 1, is equal to 13. So if I add 2, 3a is 15 and a is 5. As soon as you know a, take that bad boy up here and plug it in. 5 plus b is equal to 7. So b is equal to 2. And I've got my values. All right. Let's look down up here what our, there it is, what our problem is. And then let's integrate. So a is 5. So I've got 5 over x minus 2. That's nice. Plus 2x plus 1 over x squared minus 2x plus 3. All right, I'm going to scoot this up here so we can take a look at it. This first term, well, that's my best day ever, right? That's natural log. Over here, we're going to have to do a little bit of work. So I'm going to go ahead and split these up because I'm going to solve them differently. This obviously is natural log for my integral 1. This one, we have to do a little bit of work on, so I'm going to make that integral 2 and knock it out off to the side. So, for integral 1, I'm integrating 5 over x minus 2 dx. That's 5 natural logs of x minus 2, right? Those are absolute values. And that one's done. For integral number 2, I am integrating 2x plus 1 over x squared minus 2x plus 3 dx. Okay, well, we know we can't factor that, so that makes a difference there. So let's go for a u sub. If u were to be x squared minus 2x plus 3, du would be 2x minus 2 dx. Oh, man, that is so close, right? That is so close. What do you think we can do? This is where we get fancy. I'm going to rewrite this numerator to accommodate my du. And I can rewrite that numerator to accommodate my du because it's just a number. The 2x is legit. The issue is happening here with my number, so let's get fancy on it. I'm going to integrate now 2x minus 2. If I have that minus 2, I have to add a plus 3 to it. Because what's negative 2 plus 3? 1. All right. So if I'm looking at this, I can have this 2x minus 2 plus 3 here. And whenever we have that, we can break it up. X squared minus 2x plus 3 dx. So here's my integral number 2. Now I'm going to split this up. Because it's just common denominator, I can split it up to this one and I can split it up to this one. So I'm looking at 2 separate integrals again. So integral 2, I am going to integrate 2x minus 2 over the common denominator plus the integral of 3. Then I'm going to take this piece and do a u sub with the first one. So for this integral, I end up with 1, because 2x minus 2, over u du, right? Because I'm subbing all that out. Oops, integrating. And so then this is the natural log of x squared minus 2x plus 3 plus c. So I'm actually going to take this guy and make it integral 3. So now I have 2 parts to my integral. I have this part and I have this part, 2 parts to my answer. Now let's look at integral 3 and what are we going to do? Can't do a u sub, obviously. Oh, we're going to have to go to the next page. Let's take it over to the next page. See, some of these problems get long, don't they? That's how it works. I've got 3 over x squared minus 2x plus 3. Wow, what do we know? What are some things that we know? It's a quadratic, yep. It is a quadratic. So how can we work with a quadratic? Complete the square. You guys are so good. Complete the square. I have a quadratic. I can't do anything with that. Let's try completing the square and see what that plays out to be. So, complete the square. And I have x squared minus 2x plus blank plus 3 minus blank. You're getting good at this now, aren't you? Add that, 1, 1, plus 2. It's okay that that's not a perfect square. We can still work with it. The 3 can technically go out front, but honestly, at this point, it doesn't matter. Now, what's that pattern? Tangent, right? Inverse tangent. It's exactly what that pattern is. Here, my x is equal to an x is equal to my x minus 1. And my a is square root of 2. Good, because it's that square. It's not 2. It's the square root of 2 because it's that square. So, for my integral 3 here, that's inverse tangent. So 3 over a inverse tangent of x over a. This is an amazing problem, you guys. How much are you loving this? So my answer actually has 3 parts. My first part is this 5 natural logs of x minus 2. Then the natural log of x squared minus 2x plus 3. So I'm adding that to it because it's positive, right? And then lastly, I have this tangent. So my integral actually equals 5 natural logs here of x minus 2, because that was from the other side, right? Plus the natural log of x squared minus 2x plus 3, plus 3 over the square root of 2 of inverse tangent of x minus 1 over the square root of 2. It's indefinite. So we put on a plus C. That's awesome, right? Yeah, that's awesome. When you integrate, you just keep working with it. What do we know? What can we incorporate in here? The beauty of integrals is anytime it's plus or minus, you can break those up. You can solve them in different ways, and then you just add them together at the end when you put them all back. That's cool. Nice.